Good morning, y'all. My name is Future, and today I am going to be presenting to you. Basically, I'm going to be discussing the weaknesses of using password-based authentication. I'm also going to be exploring the alternatives to password-based authentication. These alternatives are much more user-friendly and also much more secure. So by the end of this presentation, I hope you realize the need for us to shift away from passwords. So just to share a quick story of mine. So one morning last year, I woke up to an email from my uni stating this. We received requests to deregister you from the University of Censored. After reviewing your application, we confirmed that your deregistration has been approved effective 18 October 2024. So as soon as I received this email, I was shocked because I didn't deregister myself from the uni. So how did I get deregistered? So to understand how all this happened, I would like us to first play a game. So this small game, I'm going to show you um, two versions of a web page, and you just need to spot the fake one. And then a quick disclaimer on my side, the websites that are shown in the next slides are not intended to promote any criminal activity or harm reputations. They are presented purely to raise awareness and educate on online security. So the first website, the first web page on my site is the Verts University portal. So the Verts University portal uses password-based authentication. So it requires your student number and also your password. So I'm going to give you 5 seconds to guess which one is the fake one. Anyone? The one on the right. So on your right, oh, my right. This one. Unfortunately, the fake one is the one on my left. And then moving on to the University of Pretoria one. Which one is the fake one? This one. Yes, correct. And then the next one is the Amazon login page. Which one is the fake one? Left, left or right? Left, right? We're locking in with left. Who says right? You saying right. Then who says left? Unfortunately, the one that are saying the one on my left, they wrong. The fake one is this one. So now, as we play the game, I was just trying to show you it's hard for you to actually figure out if the website that you're currently looking is the original one, right? So most of you might say, okay, the solution is that you don't need to look at the website, right? You just need to look at the URL. Obviously, the current URL that I have right now, which is a URL of a phishing website, um, that's still available online, that was created last year for the University of Pretoria. So this URL is very long, so that means it's sus, because if you use to the UP URL, it's about less than 8 characters. So this one, your brain is going to automatically trigger it. Oh no, why is the URL so long? And obviously it ends with web.app, and that's most definitely that, nah, this URL is off. However, if you go on GoDaddy, right, the people that created that long URL, they didn't take time to actually try getting a domain that's more believable. So if you go on GoDaddy, you can see if I search sars.gov.za, sars.gov.za is not available because it's utilized by SARS. However, sars.co.za is available. So imagine now, instead of using that long URL, I use this one. How many people do you think I'm going to catch? A lot of people, because they're about the same size. And sars.co.za, it makes sense because SARS is a company in SA, right? And then the next one is Take a Lot, right? This one, take a lot. The domain name is already taken. However, if you look at this one, it's missing an A. However, your brain might miss it if you're just glancing over it quickly. It might miss it, and next thing you know, you purchased, but your goods are not going to get delivered because you purchased from the wrong website. And then this one, which is even more believable because some people might literally figure the previous ones quickly, they might catch them. However, let's just say now you start your Forex journey, right? You go on xmza.com and then you register. Then you get an email. I mean, that email, if you're ever registered, you mostly get emails to deposit money into your account, right? So that's believable, right? So now, instead of getting an email to redirect you to xmza.com, you get redirected to xmza.co.za. This one is very much believable because they are companies and it's a company and it's in ZA. It's even more believable than the Take a Lot one and the um, the Take a Lot one and the SARS one. Because the SARS one you can catch it because SARS is a government company and Take a Lot is missing an A. So now most of you might say, so what's the solution to this, right? Some of you might say, okay, since we have passwords, let's just add two-factor authentication. But my question is two-factor authentication, especially the ones where you go, especially websites where you go on the website and the two-factor authentication requires an OTP that they sent on your phone. Are they really secured? So I'm just going to give you a quick demo to show you that actually those two-factor authentication, they actually, not all of them are secured, especially the ones that use OTPs or email codes or use the authenticator app. So this website, I just had to add this because it's online and I don't want to catch legal cases. So just assume the red part is not there and the caution part is not there. If you look at this website, you realize that it looks kind of like the GitHub login page. So now let's just say the user is redirected to this page, right? They get an email to log into the GitHub, they get redirected to this. So now they log into the GitHub. So they log into the GitHub, the password. So once they log into GitHub, it asks for the authentication, the two-factor authentication code, because two-factor is enabled on the, it's enabled on the account. However, what they don't realize that, so simultaneously as the user enters the username and password, the hacker will simultaneously also enter the user's username and password on the real GitHub page, right? So once they log in, it asks us for the authentication code. So I wanted to show you, when I went on my phone, I wanted to show you that the password, when it's entered in the fake website, it gets console locked on the server side. So the hacker has access to the user's login details, which they're going to use on the real website. And then because the user is trying to log into the website, they're going to go on the fake website and authenticate themselves. So I'm just going to authenticate myself very quickly. So they're going to go on the website. Let me just wait for the next OTP so that. So as soon as they enter the OTP, right, because it's asking them to log in, as soon as they enter the OTP, they get a service unavailable. However, the catch here is that also because this website is console logging the details that the user is entering, it also gets console logged on the server side. So the hacker can literally also verify using the same OTP. So from this, I want you to realize that actually 2FA is also not secure, right? So going back to my slides. So my answer to the TFA is that, my answer to TFA's, the solution to passwords insecurity is that, as you saw with my demo, no. So if this was a bank, then if this was a bank website, it just takes 2 minutes to buy a Monero. So most of you might say, okay, I won't fall for this. I agree with you. You shouldn't fall for this because you're software devs, bro. You're supposed to be checking the URLs, supposed to be verifying everything. But the problem is you're software devs. So you need to create solutions that your users, the users that, the people that are going to use your apps are not going to fall for this. So, and another thing that you might say is, okay, what if it's just a personal website, right? Then I can just use password authentication because it's easy to implement. The problem with using that password authentication as a whole is that many users, we're humans as a whole. So we end up utilizing the same passwords. So you might find that the password that a user is using on your website might be the same password that they use for their emails. So if the hackers are able to crack your passwords, it can end up creating a domino chain effect, and the hacker can end up logging into the user's Gmail account. So the solution to this is, okay, let's inform the users to actually use password managers, right? Because if we're using password managers, you can generate a unique passwords every time, and each website is going to have their own password, and the user won't have to remember them because they store it in a vault, right? You see, that's a problem right there, because password managers have a single point of failure. If the password manager goes down, you can't log into your account, right? So that means you're locked out. The worst situation is, what if the password manager gets compromised? Then what happens to all your passwords? Potentially, the consequence is lethal. So the reason why I say this is because of the rise of polymorphic extensions. Have you all heard of polymorphic extensions? So basically, polymorphic extensions are malicious browser extensions that can secretly mimic any other extension on your web browser, such as an AI extension that summarizes websites that you visit, or even password managers. So most password managers, like for example, 1Password, they use extensions so that they can autofill your passwords when you go on websites that you store the passwords for. So I'm just going to show you a quick video of how polymorphic extension attack works. It's just for research purposes. So they just made this for research purposes. So the extension is not on Google extensions. Sorry about the as. So basically, this is the 1Password. So what happens here is, let's just say I'm the hacker, right? I built an extension, a Google Chrome extension. This Google Chrome extension, the first version, I say it's an AI transcriber, right? It can transcribe your meetings. So I put it on, the first version has no malicious code, right? Because it needs to get it needs to get accepted to become a Google extension, a Google web browser extension. And then after it gets accepted, the next update, I add the malicious code. So this malicious code, basically what it's going to do is it's going to, um, it's going to go through the user's extensions and try to find one password, the password manager. And then once it finds the one password, if it's enabled, it disables it, right? And then once it's disabled, it's going to prompt the user to log in because they try to get the user's one password credentials. As you can see, the user is logged out, but they're not really locked out. The extension is just, the one password extension is just disabled. And then once the user logs back in using the phished extension, the extension enables back the one password extension. So unknowingly, the user would have actually gave out their credentials without realizing. So they would just think, okay, I'm just logging into one password to retrieve my passwords, only to find out, oh no, they just gave out their credentials. So we say goodbye to passwords and hello to passwordless. We'll forever remember them because they've been a huge part of our authentication cycle. So what's the future? What are the new players in town? The new players in town we have is FIDO, Fast Identity Online, and then we have OAuth 2.0 and Magic Links. So Magic Links, to summarize it, the user logs in by clicking on an one-time link sent via email or SMS to log in. The advantages to this is that it's easy to log in, it simplifies the user access, and you don't need to remember any passwords. The disadvantages are that if a hacker gets access to your emails, then obviously they can use the magic links that you generate to log in. And then OAuth 2.0. OAuth 2.0, basically what it does is once you click on Google Sign In, it redirects the user to a service authorization page, and then it grants so the user is going to grant permission for the app to access the email and also username. And then from there, the Google provider is going to generate a token that the app or service is going to use as authentication. So the advantages is that it's similar to the magic links, is that it simplifies user access and the user does not have to remember passwords. But the problem is data risk. So if the provider app gets exposed, then the hackers can get access to all the services that you authenticated to, and it's harder to implement securely. And then the last one on my slides is FIDO. So FIDO comes into implementations. You can have the hardware, the secret key implementation, and the biometrics implementation. So with the biometrics implementation is you're going to use your phone to authenticate yourself. So when you authenticate yourself, it compares the template that, sorry, so when you sign up, firstly, it generates a template of either your face picture or your fingerprint, and then when you log in, it compares that from your device. So your details, your biometrics details, are not sent over to the server. Only, and then from there it generates it generates a private key pair, and then registers the public key on the server that you're trying to authenticate with. And following all logins, the service that you're trying to use, they're going to be communicating via the private key encryption. So yeah, that's the end of my presentation. I hope you see the need for us to switch to passwordless. Thank you.